today we are going to be looking at solving systems of equations by graphing. So we kind of touched base on this before. And the other days we started talking about systems of equations first as, what are they? And we said it's two or more equations that all work hand in hand, right? So it can be two equations in a system, it could have three equations or four equations, but there has to be some solution that works for all of them. And then we talked about checking if a coordinate pair was the solution to a system of equations, right? And how, thinking back, you guys, I want you guys to type in the chat real quick because I'm trying to have to where I'm not just talking the whole time. I want you guys to tell me, how did we check a coordinate pair? How did we check if it was a solution to the system of equations? So I'll say that again. How did we check if a coordinate pair was the answer to a system of equations, a solution to the system of equations? How did we check that? So that was last Tuesday. I know that was a while back. But how could we check to see if it's a solution? What do you guys think? No wrong answers, just... So what do you guys think? You can put it in the chat. So if you need a visual, see, I could maybe do that like this. So let's say we had, I don't know, y equals 2x plus 3. I'm just making up an equation. Okay, and the other equation is y equals x minus 2. So we have a system of equations here, right? Two equations that are working in one system. And let's say that we were given a solution like 3, 2. And we said, is this point right here, is this a solution to this system? Do you remember how we checked to see if it was? How can you check many of your answers? If you have an answer in math and we say, is this the right answer? How do we usually check? What's the kind of general thing that we usually do? Go ahead and answer in the chat. What do you think? What do you think? You type in an answer there, Emmett or Edna? And if you guys, if it's easier, you can unmute your mics. Okay, today if you want. Alrighty. Emmett, did you say you were posting something? Okay. That's all right. So, good. So a system of equations, it will be where the lines cross. If it's just like this, if you can see my screen here, guys. If we just have the coordinate pair and the system here, we can plug in our values, okay? And that's what I was just trying to get with you, connect with you guys earlier. Because like when we solved, not systems of equations, but when you solve like a two-step equation or things like that, and you solve for x, right? You get like x equals 2. And then instead of just saying, okay, I guess that x is equal to 2, what we should do is check it, right? We should say, okay, x equals 2. Well, now I take, if that's true, then everywhere I see an x in my equation has to equal 2. So I take my 2, substitute it into my equation, and see if it works, right? See if it makes a true statement. So that's what we're doing here. The only difference is we have an x and a y. So we would plug in the 3 for all my x's and the 2 for my y's. And if they both make a true statement, then it would be true. Okay, so let's go ahead and look at our first one together here. So that was, sorry, backing up for a second. So we started out saying, what is a system equation, and how do I check if I have a solution, like we just talked about. And then on Thursday, we talked about if we have two lines that are graphed, where is the solution and what is it? And it was where the lines intersect, right? Today, we are the last little bit to just start from two equations and find if they are, find what the solution is to graph them and then find the point of intersection. So we're just doing all those things together. Graphing the two lines, seeing where they intersect, that's the solution, and then checking it. Okay? So we already said this, the solution is the point where both equations meet. Okay, if they're parallel lines, are they ever going to meet? What do you think, guys? And we did one of these on Thursday. If they're parallel lines, are they ever gonna touch? No, exactly, guys. So if they're parallel lines, they could be a system of equations, but if they never touch, then there's no solution. Okay? And if it's the same line, one line right on top of the other, then it's infinitely many solutions. Because it's like they hit here, they hit here, they hit here, they hit here, right? It's all on the same line. Good. All right. So you guys are going to do this along with me. But let's just take a gander at this first guy here. So the first one we already did for you. And let's see if I can zoom out a little bit. Sorry. View, zoom out. There we go. Okay. So if we are solving this, so like I said, this is how it's going to look like when you guys finish each of these, or when we finish each of these. You're going to use the red dots to place your y-intercepts. Okay, and I'm going to draw that on here. And you can maybe draw this on yours too if you want to make sure you remember it. So for this activity, I want you guys to use the red dot for y-intercept, blue for all your other dots. So I'm going to say other, oh man, rats. Okay, I'm just going to write it. All right, blue is for your other points. Other points. And again, you can be writing this in yours as well. The line is obviously going to be our line, and then green is going to be where the two lines intersect. So that's going to be your solution, right? All right, so that's going to be our solution. So if we start each of these equations out, we don't have this, right? We don't have our solution yet. We just have two equations, y equals 2x plus 1 and y equals 3x minus 1. So if we were going to solve this, and again, yours is like this, so you can actually move your pieces. So graphing a linear equation, this goes back to a little bit of review and back to what we did earlier since we've begun distance learning, is we place our what first. Where do we start when we're graphing linear equations? You guys remember? What's the first thing you do when you are graphing linear equations? Okay, maybe finding our x point first. Good. What do you think, Emmett? All right, so we have two equations here, right? They're both in slope-intercept form, which means that they have a slope and a y-intercept. So they're called slope-intercept form because the slope comes first. Yeah, the slope comes first, and then the y-intercept comes on the end. Okay, so y equals mx. M is your slope, whatever is in front of the x. And whatever is on the end is your y-intercept. So you're going to start with your y-intercept. That way you have a starting place on the y-axis. So we're actually going to start with our y-intercept. So what is the y-intercept of this first equation here? What do you think, guys? It's the slope-intercept form of a linear equation. So which part of this is the y-intercept? Good, the positive one, right? So we take our point and we place it at positive 1 on our y-intercept. Okay, easy enough. And then we can actually do the same thing with the second equation. I'll go ahead and do both of them at once. So that next one is at -1. Okay. But I'm just going to worry about this first equation for now, actually. So y equals 2x plus 1. We already placed the 1, and now all I have to do is look at my slope, which is 2. And we know that we can write 2 as 2 over 1 if I needed to, right? I could always put anything over 1, and it doesn't change the value. So now that it's 2 over 1, this is rise over run. That's the way we remember slope. And we say, okay, so rise 2, or up positive 2. And it's a positive 1, so up 2, right 1. And then I place a point. Up 2 over 1, place a point. Up 2 over 1, place a point. And you can do that as many times as you want. Up 2 over 1 to get your line, okay? So then now we have our line. We're pretty close at least for our first one. Okay, and then we need our second one, right? So then same thing. We start at -1 on this one because it is, the y-intercept is -1. Okay, so we place our red point there, and then we say our slope is 3, aka 3 over 1. Okay, and so now we say rise over run is our moniker to remember. So we say rise over run. Okay, 3 over 1. And they're both positive, right? Positive, positive. So 3 over 1, so we're going to rise 3. 1, 2, 3, and run 1. Place my point, and I can do it again. Although it looks like I'm missing a couple dots. Okay, so I said rise 3, run 1, so I'm going to do that again. I'm going to say rise 1, 2, 3, run 1. Rise 1, 2, 3, run 1. Okay, and that one would be somewhere up there. All right, so then I would graph my line. And I would be noticing where they intersect, and it looks like it's going to be right here. So I'm going to place my green dot right there. Okay, so then I say, okay, it looks like my solution's at what is that point there? 2, 5. And so I would say 2, 5, I think is my solution, which is what we have right here, right? 2, 5 is our solution, and then I can check our solution. So to check it, all we do is we take those values, and what do we do to check again, guys? What did we just go through saying? How do we check if we have a coordinate pair? What do you think? We take our answer, our coordinate pair, and what do we do with it? Go ahead and answer in the chat. What do we do to check our solution? You're going to take it and you're going to, it starts with an S. You're going to what? Okay, that's all right. Emmett, you have a you have an idea? Okay, so make sure you're listening carefully then this time, both you guys. Is once you get your solution, if you have a coordinate pair, you substitute it in, okay? Substitute your solution in. That's how you check your answer on most math problems. So, and this one is no different. So if you're looking at my screen here, this 2, 5, that's what I need to check. So I take my x value, and I'm going to substitute it in for the x. So I'm going to write that on here. So I would take this 2, which is my x, right? And 5, which is my y, and substitute them into the original equation. So let's do that real quick. Y equals 2 and then times x. But instead of x, I'm going to substitute my 2 in. And then plus 1. That's the first equation, right? And then I have to check both. It has to work for both equations. Otherwise, it's not a solution. So y equals 3 times x. And instead of x this time, I'm going to put my 2 again. And then the minus 1. And then I need to replace these y's. And I could have done this at the same step. This needs to be a 5, and this needs to be a 5. Okay, now we check to see if it works. What is 2 times 2? 4. 4 plus 1 is 5, so this one works, right? 5 equals 5, that's a true statement. So I got this one correct. That's it works for that one. 3 times 2 is 6. 6 minus 1 is 5, so this again says 5 equals 5. That's a true statement. So this is our solution for this system of equations. Okay. Let me, since we're, I'm going to have you guys do the next one with just a little bit of aid from me, but I want to see if you guys have any questions on that. Hopefully that's making a little more sense. You can give me a clap for no, clap reaction for no, thumbs up if you got it. All right. Then if not, then let's go ahead and try this. All right, class, I want you guys to try this next one on your own. I'll give you guys scaffolding on how to start, and then I'll have you guys do it. What is our y-intercept for the first equation on here? I want you guys to put that in the chat. What is the y-intercept? You can do both. What's the y-intercept for both of these equations here? Okay, -2 and 6. Do you agree or disagree, Emmett? Wonder if he got pulled away. All right, it is going to be -2 and 6. Good job, Edna. Awesome. So if these are our y-intercepts, that's awesome because then we know where to start, right? We start at -2 and we're going to start at 6. So I come over here and I say, let me grab my little dots, and I actually can't grab it on this one, right? So let me switch back over. So on your screen, you can do this because you've made your copy. And you say, okay, red dot, it's at -2. So I go, again, on my y-axis because it's a y-intercept. And I place my -2 best I can. Okay, and then I'm going to say, what's my slope? It's 2. Or how can we rewrite 2? Again, I want you to put it in the chat. How can we rewrite 2 to make it to where it's rise over run? What do you guys think? What number can I put any number over or divide any number by that doesn't change the value? So what number can I divide 2 by that would not change its value at all? Okay, maybe we could divide by 4. 2 divided by 4 would reduce to 1/2. So then the value would be 1/2 instead of 2, though. That's the only issue with that one. But what if we divided by 1? We divide by 1, 1 goes into 2 times, so then my answer is 2 still. So we can actually put a 1 under it, which you guys learned me a couple of years back, is you can divide anything by 1, just like you can multiply anything by 1. And does it change anything? Not really, right? So that's what we can do here. We can say, okay, instead of calling this 2, and we're just doing this just so we can think of it as rise over run. Okay, I mean, the slope is still 2, right? But this way we can say, okay, this is my up and down movement, rise, and this is my left and right, my run. Okay, and then you'll do the same thing with this one. -2 and put it over 1. That way, again, we have rise over run. Okay, so let's do that with this one. So we already placed our -2. Good job there, Edna. And now we have 2 over 1 for our slope. So we're going to say that means, again, 2 over 1, so rise over run. So 2 over 1, rise over run. That means we rise +2. If we're rising +2, do you think that's going to make us go up or go down? If it's a +2. Good. It's going to take us up, right? So we'll go up to 1, 2, and then it's a positive 1. So that's going to make us go to the right. So up to, right 1, and then we keep doing that. Up to, right 1, up to, right 1. And I want you to go ahead and do this on your sheet as well, okay, guys? That way you guys get the practice. All right, so, and then I can grab some of my lines. I can rotate them. I can stretch them out. Okay. So there's my first line, and then now I do my second line, okay, which was the plus 6, right, and the negative 2 over 1. So we already rewrote our slope as this, negative 2 over 1, and and then plus 6, you told me, Edna, that that's our y-intercept. So we say, okay, y-intercept's at 6. So I go 1, 2, 3, 4, 5, 6, place my dot, and then from that point, I then do my slope. So if it's a negative 2 over 1, if that's a negative 2 for the rise, do you think that's going to go up or down? What do you guys think? If it's a negative 2, is that going to be up or is that going to be down? Good. It is going to be down. So if it's a negative, right, it goes the negative direction. So instead of up, which is positive, it's going to go down. Excellent. So we go down 2, 1, 2, and right 1. Place our point. We do it again. Down 2, right 1. That actually looks like our intersection. Down 2, right 1. I'll do a couple more though. All right, and so it hit the line. Oops, sorry. Okay, it hit our line right there. So that is going to be our intersection slash, that's going to be our answer, right? It's going to be our solution. So we say, all right, here's our 2 lines. Close to it anyway, right? It's a little hard to do it here instead of paper. But we've got our 2 lines, right? And they're intersecting right here. That is our solution. So what is our solution? Emmett and Edna? What would our solution be on this one? Oops. So where is this point located? Remember, every coordinate pair is an x and a y. So how many to the right is it from the origin? So from right here, okay. Exactly, yeah. I was just asking where the solution was. So it'll be 2 over, right? And 2 up. So 2 comma 2, right? X is 2, the y is 2. So that's what we're going to write in here. So we would say our solution is 2 comma 2. And that's our answer, okay? And then to check your solution, we substitute it into our equation. Okay, so I look at it the original way and I plug in my values, right? So I'm going to go ahead and do that real quick. And then I'm going to have you guys do one of these all on your own. Okay. So we've got y equals 2x minus 2. 2x minus 2. And y equals negative 2x plus 6, right? And we just got our answer on that other one. Sorry, it's 2 sheets, I know. So we got 2 lines here going on forever, and they hit right here at 2, 2. So we're checking this answer, right? That's what we're doing. So to check 2, 2, I'm going to substitute both of those values in. Okay. So where's my x's? Wait, right here and right there, right? So I substitute, aka plug in, a 2 for my x's and a 2 for my y's, right? And see what we get. So quick maths, 2 times 2 is 4, right? Minus 2 takes me back to 2. So this now says 2 equals 2 up here. Is that a true statement, guys? 2 equals 2, is that a true statement? Yes, good. So that one, it works for that one. But if it doesn't work for the second one, it won't work. So let's see. Negative 2 times 2 is negative 4. Okay, negative 4 plus 6 is going to be positive 2, right? 6 take away 4 is 2. So 2 equals 2, is that a true statement? Yes, it is, right? And so we know that we got it correct. Okay, and once again, that's a nice thing about this part of math is you can know if you got your answer correct. There's no, it's not like, did I get it right? I don't know. You can always check and see if it worked, okay? If it didn't work, if one of these, if you got like 2 equals 3, you would say, that's not right. So you'd have to go back and check your graph again. Okay? So, all right, this last one I want you guys to try on your own, and then we'll go over it together. Okay? So on your slides, you'll be able to move the little dots, right? So I want you to place your y-intercepts and then do rise over run and get your little graph lines and make your lines. Alrighty? So go ahead and give that a go. I'll give you guys quite a bit of time just to make sure you can play around with it and get it right. But we do need to keep moving on as well. So we'll say maybe 2 minutes. Okay. Place your y-intercepts and then get your slope. And if I'm still full screen, you can press escape. That way you have room to write. If you have questions while you're doing this, you can ask them in chat. And then after this, we're going to do our activity, and that will take us right to the end of class. Okay, we'll say about 1 more minute. Make sure you guys are getting your solution. I'll reshare in a sec. Okay, once you think you have your solution, I want you to go ahead and type it into the chat. So I know that you're done and you have a solution that you think you got. All right, so let's see what you guys got. Okay, if you're still finishing yours up, I'm assuming you are since there's no solutions there. That is a-okay. Just be checking along as I share with you guys. Okay, so here's what mine's looking like. And again, you can have your screen up too. That way you can be finishing up while I'm talking. So I just placed my +6 plus 6 y-intercept for the second one. And I actually didn't do this one right because I did the wrong slope for that one. So +6, and then my slope on that one is -3/1, right? So I could say -3, or I could call the slope -3/1. The only reason I would change it or make it look like -3/1 is so I can think rise over run, rise over run. So rise of -3, that's really going down, isn't it? It's a -3. So rise, quote unquote, of -3 makes it go down 1, 2, and 3. Okay, so down 3, right 1. And then I do it again. Down 1, 2, 3, right 1. Okay, and so on. Down 1, 2, 3, right 1. Okay, and then I can draw my line. Okay, and then I do the same with the other one. So I've got -4 as my y-intercept. I already placed that. My slope is 2, or I could say 2/1. So that way I am thinking of rise over run. Rise 2, run 1. Rise 2, run 1. So up 2, right 1. Rise 2, right 1. Rise 2, right 1. Okay, and so then I have my line. I finished drawing my line. And it looks something like that. So my intersection, my solution, is going to be right over here. And it looks like it's at 2 comma 0, right? So that is going to be my solution, 2 comma 0. And that's my solution. And then I just check to see if it's if that's right, because I want to get it right, you know. So I say, okay, let's check. Let's plug in 2 for my x's and 0 for my y's. So 2 times 2 would be 4. Minus 4 would make 0. So this top one now would say 0 equals 0. Yeah, that's true. And then I do the second one. Negative 3 times 2 is negative 6. Negative 6 plus 6 is 0. So that one works too. So I know for a fact that I got my question answered. Okay, so 2 comma 0 would be our solution on that. Okay? Any of you guys get that? Did you guys get 2 comma 0 for your solution? Nice. All right, good job, guys. So now is our activity for the end. I want you guys to go to that Desmos link now. Okay, and when you head to it, it's going to have these different screens like this, and it'll ask you different questions about the steps of solving. So for example, this one just gives you a picture, and it says, identify and label the solution on the graph. So then it looks like I could say, I could like circle it, right? Or I could draw an arrow. Okay, and then it says, what is the solution to the linear system? So I would say, okay, well, where is that? That's at 1 comma 1. So then I could say 1 comma 1 is my solution. And then it says explain why. So I could say, because it is where the 2 lines meet. Okay. So something like that. Okay, and then you'd say, all right, next. And then you answer this one. Okay, and it has a couple different types of problems. This one has you graphing the 2 lines, and then you put your solutions there. So follow the instructions, and then I'll have you guys share with me your answers at the end. Okay? And the point of doing this is if you get stumped or you need help, then ask me and I can help you, okay, as you go through. Alrighty. So I'll go ahead and let you guys get started. And I will have mine up, ready to assist you. Good, guys, and I'm playing around with this a little bit. I will, um, once you finish, as you're going through these, I'm going to make little comments on your answers. That way you can get some feedback as you go through, okay? Edna, will you... Oh, wait. It didn't save. Sorry, I was trying to make helpful comment here. Good job, guys. Make sure you're staying on task. If you need help. I'm going to make private comments to you guys in chat because it won't save my comments on Desmos, apparently, for now. So have your chat somewhere to where you can read it as well. Sorry. Looks like you're pretty close there now. If you're doing the blue one, you started it in the right place. Good, at -2, and then you go up to right 1. Up to right 1. So more along the lines of here. For your blue one. And then you can do the green one. Good. Good job, guys. You're doing good. You're doing well, I should say. just a couple more, guys. Yeah. One more minute, and then I'll let you guys pause on yours for now. So maybe finish up the one you're working on. Okay. As you guys are finishing that one that you're wrapping up, listen carefully to this instruction, okay? So first of all, thank you guys for joining us. You guys did awesome. Hopefully you'll get some more participation. I encourage you guys to make sure you're always in here so you can always get help as well. So two things. I only want you to do, let's see. Yeah, I only want you guys to do numbers 1 through 6, and I'll put that here in the chat. Okay, so I think there's 12 problems on here, but I only want you to do problems 1 through 6. If it'll let me save my comments, I'll have comments on there as well. But once you guys finish, I want you guys to, you'll do the print screen, right? How we did the screen capture the other day. And I want you guys to paste a picture of your screen here once you're finished, okay? Or send me an email. So you can either paste it here. I would recommend maybe pasting it here and then sharing this with me. That'd be an easy way to do it since it'll be a slide page. You can share this with me once you've pasted it, or shoot me an email. Okay, and then that's going to be at granitesd.org. Okay, so problems 1 through 6 for the assignment. sd.org. And then the only other thing, guys, is on this last slide. Once you finish on the Desmos, I want you guys to go to this link here and do AA2. Oh, I'm not sharing, am I? Real quick. Okay, everybody see my screen? The last slide in the slideshow, I was saying you guys, or the second to last one, you can paste your screen capture here and share this with me. Share like that. And then the only other assignment is IXL practice AA2 to 80, okay? And it's maybe even a little less work than the Desmos one, okay? You just have to use the little graphing tool that they have, okay? So AA2 to 80, and those 6 problems that you guys are already partially done with, and that's the only thing you have to do on Thursday.